Good morning, everybody. Thanks for joining me today. My name is Stephanie Kim. I'm a developer with the Apollo Education Group. We have an office in Seattle that I work out of. Today we're going to talk about how to investigate user experience with natural language processing and analysis. So first, we're just going to go over some broad definitions of what I'll be talking about. And then we'll kind of go into more of, how to help the user through learning what issues they might be having with your UI. So first, natural language processing. It's the field of computer science dedicated to understanding natural language through machine learning and computational linguistics. And when I talk about natural language, I'm talking about everyday human spoken language versus artificial language such as programming languages like Python. So, blah, 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 what does that all mean? It means we can use statistical models and probabilistic algorithms to answer business questions to make informative decisions. And there's a little cartoon from XKCD. He wasn't really happy with her graph, but anyway. She was trying to prove her point with data. She kind of did, but not how she wanted. So why do we need data to tell us what to do? There's a lot of talk about data-driven design or decision-making. I don't really like that terminology. I like it more to be data informative. Like you want your data to inform you about what your users are doing, but not necessarily take it as complete truth. So, first of all, you would be really surprised at what the user is thinking, doing, and having problems with that you might not realize. So through feedback form data, you can actually gain some insight to that, but you actually have to do some analysis on that feedback form data, not just throw the feedback form on your website, kind of forget about it. You actually have to look at the comments and look at what people are saying. Users actually have some pretty cool insights and suggestions for making your product better. They're the ones that use it every day. And they might have a simple suggestion like, hey, I can't find this link, or oh hey, could you put this feature on? That would really be helpful. And if they're thinking it, probably a lot of other people are too. So you can also gauge how releases affect user sentiment. Because you can do like a time series analysis, and you can look at sentiment and break it down by release dates, and that's kind of interesting to see how like maybe a big design change affects the user's sentiment and how they are thinking about your site. And you can also find, we don't like to admit anything gets past QA, but it does. You can find bugs and design issues that might have been missed. And of course, with all these new insights and all this great user feedback, you can gain opportunities to run A/B tests based off the actual feedback instead of just maybe the business owner's intuition. So what is the user thinking? Are they happy, sad, super pissed off? We should really find out, don't you think? I'd like to know what my users are thinking about my product. So our goal is to find possible points of friction and general user sentiment of textual data. So as a developer, by the way, I should say a little bit about my background. I'm a developer, not a data scientist, not an analyst, not a statistician. So it's a lot to learn as a developer. We don't have data scientists, we have analysts, but I took on this project because I had the time, and I know Python and a little bit of R, and I can write SQL queries, so that's how I got to do it. So first you want to identify your data set. So where is it coming from? Is it coming from, say, Adobe Analytics API? Is it coming from a CSV file or the database, straight from the database? How big is your data set? That can affect what model you might choose. How much pre-processing does it need? Generally, user comments need a lot of pre-processing. You need to figure out about dropping empty records, filtering out testing IP addresses. There's just a lot of cleaning up that you probably need to do. So next, you need to identify the tools you will need. And this can kind of be a little bit, it's really great because there's all these great tools. And, not only Python tools, but, our tools as well. But you want to focus on solving your problem and not get caught up on what everybody is using at the time. Everybody's talking about this algorithm or that one. So you want to read the forums and tutorials to kind of figure out how to solve your problem and not get caught up on, what's the latest and hot topic. So this one is pretty important because it'll decide on your structure of your scripts. So you want to decide whether your report will be automated or ad hoc. You want to figure out how often will you run it. Sometimes business owners will be like, oh, we want this run daily. And you're like, no, that's not going to gain any insight. So you might want to run it weekly, especially for feedback form data, because users are commenting on a daily basis, but say your sprints run 2 to 3 weeks, so I feel like a weekly turnout of that is pretty good for gaining insights and catching maybe things that you want to catch in a timely manner. And so if it's automated, you also need to think about whether you want to use tools such as IPython Notebook. It's great for quick iteration and development, prototyping, but if you do want to automate it, you're going to have to take what you did and make it into a script that won't irritate the next person that will come and try to work on your code. So next, we're going to talk about methodology used in text mining. So you've got categorization of features and you've got information retrieval. And both are useful, but they're kind of useful in different ways. Categorization of features, you've got cluster analysis, and that's a good way to find patterns in your data that you might have missed, such as clusters of terms that are commonly found near each other in a vectorized space. Sentiment analysis, which is probably the majority of what we're going to be talking about today, using a supervised machine learning model, such as the Naïve Bayes classifier, or you can also use a lexicon-based approach to determine how users are feeling about your product. This actually ended up being one of my favorites and pretty insightful is the time series analysis. So you can monitor user sentiment based on release dates, as I talked about earlier, or other variables to identify changes over time. So you can also do lexical dispersion. So you just take the most frequent words with maintaining order of those words in the corpus to determine the most talked about terms through time. And it also can be separated via sentiment classification. So normally like a lexical dispersion plot would show you the word offset, but because you're maintaining that word order, you can also kind of look at the most frequent words, how they change from like, say, 2 months ago to now, especially like if you're separating it in sentiment classification, you can have a negative classification plot and a positive one and see, okay, how many times did we see difficult, can't, or won't let me, because you don't have to use just unigrams, you can use bigrams or trigrams, so look at kind of word phrases and stuff. So information retrieval. So this ended up being, after of course you do the sentiment analysis, this I felt was the most beneficial, even though it was like the 2 smallest functions I wrote for this project. So basically, you're just taking word frequency in the corpus. You're not maintaining word order. You're not caring about grammar. And you just apply a search functionality, finding those frequent comments. And I found about like the top 25 to 30 comments, the top 25 to 30 most frequent words, searching for those in your corpus and in the comments. Those comments you have to then manually read, and there you can find different issues that are common with those frequent terms. And those frequent terms aren't always opinion words. A lot of times they're about your product. And so it's actually really beneficial to look at and read. And yeah, there is manual work in it. But that manual work will definitely give you way more insight than any, visualization or model will show you. So how can machine learning help us do all this? Normally, a lot of times you hear machine learning for image detection, spam filtering, providing recommendations for customers with a recommendation engine, speech detection, and then, of course, natural language processing. So I just felt like we needed a cute little animal. So I put this machine learning to the rescue. So yeah, you'd have to label a lot of your data to get really useful insight. And that's why machine learning is great, because you don't have to label all your data. So here I looked for, through dozens of definitions of machine learning, and I hated almost all of them because they were either really technical or just really dry. I found this from lecture notes, and I just thought it was a really human-friendly way to describe machine learning. So machine learning studies computer algorithms for learning to do stuff. We might, for instance, be interested in learning to complete a task or make accurate predictions or behave intelligently. The learning that is being done is always based on some sort of observations or data, such as examples, direct experience, or instruction. So in general, machine learning is about learning to do better in the future based on what we experienced in the past. And so the main point is, you're trying to automate decision-making with computers. So first I'm going to talk about unsupervised machine learning, because it's a lot of times used for exploratory analysis, so it's kind of a good starting point if you really don't know much about your data. So the key points that make it an unsupervised model versus a supervised model are that training data is unlabeled beforehand. It's used to find underlying structure of data based on statistical properties such as frequency. It's used for exploratory analysis to find unrealized patterns. And it's used when there's a lack of labeled training documents. So there's just some examples of models. I have seen maximum entropy classified as a supervised model and unsupervised, so I guess it depends upon what academic papers you read. So I'm going to be talking about k-means clustering a little bit here. So it's used, again, for relationship discovery and understanding the underlying structure of data. It's useful for unlabeled data as the first round of analysis. It makes no assumptions on the data. You manually have to give it a target number of clusters, and that's usually done using the elbow method. It utilizes distance metric in clustering algorithm, so its objective is to minimize the average squared Euclidean distance. And yeah, so there's tons of tools. There's so many good Python, developer-friendly tools to use to accomplish running models such as the k-means cluster. Scikit-learn and NLTK are two. The scikit-learn's TF-ID vectorizer or the word-to-vec library can be used to vectorize words, giving textual content a numeric value, because that is the one thing you need with the k-means. It has to be numeric value. So I actually didn't find this to be entirely that useful. It gave me some cool groupings for, frequent terms, but then you look at that and you're like, okay, well, what can I do with that information? And it is kind of interesting, to see, oh, okay, well, this term is, near that term, but beyond interesting, I didn't find it useful. So supervised machine learning. So what makes it supervised? Let's see, the classifier is called supervised if it's built based on training corpora. And corpora is just, if I haven't explained that before, it's just your text content. So corpora could be like, sentences, or it could be a book, or comments in our case. So it can, the trained corpora has to contain the correct label for each input. It's used when a large number of labeled training documents are available. And here's some examples of popular supervised machine learning models. So I'll be talking about the Naïve Bayes Classification. It's the one that, when I was looking on what model to use to classify sentiment, this one came up a lot. And so I gave it a try. And it actually did pretty good. The lexicon-based non-machine learning method does actually about the same for me, for my domain. But anyway, so when used for sentiment classification, the inputs are classified in isolation, having no effect on other inputs, meaning they're atomic. One doesn't affect the other. Labels are assigned in advance, and that's kind of the tough one, because that's a lot of manual work. You want to create a training, you want to create training data that's based off your domain. And so you actually have to go through, like in my example, doing sentiment analysis, you have to go through comments and score those yourself. I did try to use other training data to cheat, and it doesn't work very well. Feature detection is decided in advance, and that's one of the most important ways to increase the accuracy of your model. And a lot of times it's just narrowed down by trial and error, trying to identify features that result in a classifier with higher accuracy. You can do this with n-grams, so unigrams, bigrams, and trigrams. Stemming, stop words. I found that unigrams performed really well. Stemming decreased accuracy, and stemming is just taking a word to the root. And stop words, you can either include stop words, English stop words, or articles, or you can exclude them. And those are, just words that are commonly found in the English language, like to, but. So those can be included and excluded. And classifiers are created by training them on labeled data. So again, the natural language processing kit contains a Naïve Bayes classifier to classify data based on trained data. It's just, again, super easy. All these tools are really easy to use once you figure out what you're supposed to be doing in the first place. It includes perceived accuracy and likelihood ratios for comparing feature to outcome relationships. The perceived accuracy, that's actually and that's taken from their book, it is perceived. Because when you manually go through and check accuracy, it's definitely not as accurate as the model's perceiving it to be. But I should say that humans only agree on sentiment about, I think I read 80% of the time. And so if your model's about 69, 70%, from what I've read from academic papers, that's usually pretty good. I think 2 different Stanford papers say 60 to 65 is actually acceptable, which seems really bad, but you can still gain insight. So I also tested against a lexicon-based non-machine learning method. So this method relies on sentiment lexicon, and it matches terms in a dictionary with those in your corpus. It a lot of times focuses on just adjectives, so those are opinion words with their labeled sentiment. I do want to point out that, I mean, there's a lot of dictionaries out there that you can use, like there's even text for Twitter sentiment and whatnot, but you can start with those, but it's really, really important to add and customize those dictionaries by adding domain-specific terms, because there's a lot of terminology that is in your data, your comments, that a regular dictionary is going to misconstrue as either positive or negative. So say you've got a product that has the word interest in it, or interest. Well, interest in, these dictionaries, these sentiment dictionaries, is a positive word. Well, what if it's just a pronoun in your terminology, in your domain? Then you need to kind of neutralize that, or else the scoring will be skewed. So there's also another way of doing, that's the manual creation of a dictionary, meaning someone went in and took words such as great, happy, sad, and gave them either a numeric value on a scale from -5 to +5, with neutral being 0, or it could be a string, positive, neutral, negative. But there's also the automatic creation of a dictionary. And that way starts as a list of seed words using statistical means such as point-wise mutual information. And that it just associates a word with a set of positive and negative seed words to find synonyms and antonyms in the corpus. So how easy is it to properly classify data? This pretty much sums it up. Can everybody read that, or should I read it to you guys? When a user takes a photo, the app should check whether they're in a national park. And of course, this is the business owner, I'm assuming. Sure, easy GIS lookup, give me a few hours. Oh, and check whether the photo is of a bird. The developer says they'll need a research team in 5 years. And yeah, at the bottom it says, in CS, it can be hard to explain the difference between the easy and the virtually impossible. So yeah, I'm a developer, probably some of you are too, not research scientists. We're not all research scientists and statisticians. So why aren't we leaving it up to the experts? Well, do you have a team of research scientists on board? I know my company doesn't. Can you afford to pay vendors for their software? Well, maybe. But there's also additional work that needs to be done, like I've talked about, to customize the reporting that maybe only internal developers and analysts will know about, such as what I was talking about, specific words in your domain that will skew the results if they're not either removed or neutralized. And really, why let someone else have all the fun? Because it's a fun type of project, and you get to help your user based off their direct feedback, which actually feels pretty amazing. So accuracy. As I talked a little bit before about what's acceptable for accuracy, this part as a developer will cause you to fall down the rabbit hole more than anything in this type of project, because you can always tweak it. You're always learning something to make it better. So at some point you just have to stop and say, okay, this is good. We've, gained a lot of insights. And then of course, in a couple weeks, you can always back and tweak it some more if you really want to. So there's error checking and model validation. So if you choose to have too many features, I think the NLTK's example is gender identification of first names. And so a feature would be the last letter of that name and whether it ends in a Y or an S. I can't remember the details of that. But when you take the first letter as well as the last letter, having more than one feature, it actually decreases the accuracy of the model. So that can cause the overfitting. So what n-grams are more accurate? From what I've read, I wish I had have read it before I did it, before I played around with it so much. But unigrams tend to actually be more accurate than, say, bigrams or trigrams. So one word versus like 2 or 3 words. And that's the trick. I mean, you have to find the right information to read before you start these projects too. And sometimes you just come along stuff and you're like, oh, I wish I had known that. So does stemming help or hinder the process? Again, this has been found this is a real quick, there's a stemmer in the natural language processing kit that it's really easy to apply, so it's really fast to figure out whether this actually is going to help you or decrease accuracy. And then stop words, do we include or exclude them? This one is a little bit trickier because it kind of depends upon the model that you use too. And so, error checking with using confusion matrices and cross-validation to check accuracy and compare models. And again, I think the scikit-learn has, it does. It has this too, and the natural language toolkit has it as well. So you don't have to write those, that functionality yourself. It's all built into the tools. So someone told me I needed more visuals in the slides. So this is what I made. I suck at visuals, so, but it's a visual with text. So it just kind of goes through the workflow a little bit. You're wanting to do first data extraction and pre-processing. And I've kind of talked about some of this stuff before. Feature selection and extraction. Negation modifiers is really important, and that's why I expected bigrams to be more useful than unigrams, because not good changes the meaning of good and such. So that actually kind of surprised me. But then, you've got implement your classifier after you've, of course you have to choose that classifier first based on what your data looks like. And there's some options. And I just started reading about maximum entropy, and I don't know enough about it to really explain it, but from what I've read, it a lot of times beats the Naïve Bayes classifier, so I'm going to try that one next. So, which classification model should I use for sentiment analysis? There's no easy answer because it depends upon your domain, it depends upon how much data you have. But the basics are, how much time can you commit to this project? Is this gonna be, some, hurried, like, half-ass, projects that you do on the side, or are you going to really be able to dedicate a couple months to learning and doing this? Because each model takes a different amount of time to set up. And also, each model takes a different amount of time to understand the underlying algorithm, and it is important to understand what each model is doing, so you understand which, some of the different features that might help that algorithm, like the Naïve Bayes needs unigrams. So that's something that's really important to know before you start playing around with the different features. So I found that the lexical-based approach is the easiest to understand. You're just matching, you're just matching terms in your text to terms in a dictionary and grabbing the sentiment of those terms. So that's obviously super basic and easy to understand. The Naïve Bayes is probably, I think, the easiest of the probabilistic models to understand, and it does take more time to set up because you have to label your data, and sometimes, you don't have to personally do it, but sometimes it's hard to wrangle other people to do it, whether they're business owners or developers, but I think it's important, to get more than just yourself labeling these because, as I said, about roughly 80% of humans actually agree on sentiment of words or whole sentences. So maximum entropy out of these examples probably takes the longest of the three to set up, and it's more complicated to understand. But since I've read recently that it sometimes beats the Naïve Bayes classifier, I'm definitely going to take the time to look into that and learn about it more. So what about accuracy? Every model's accuracy changes based on the domain and training data used. And again, I say, you can't use movie review comment sentiment and expect it as your training data set and expect it to be really accurate for, say, user feedback comments, because it's not. I tried. How big is your data? Small data set. You want to stick to high bias algorithms that will more likely cause underfitting versus high variance algorithms that will overfit. And remember, feature selection will affect the algorithm as well. And there aren't a lot of good answers on this. Like, I searched everywhere about, what's the best one, and it seems like everybody's playing with everything. So in most of these, once you get your data pre-processed, and it actually goes pretty fast. And once you understand like the basics of the tools, understand the underlying algorithms and models, that doesn't take as long as you might think it does. So I'm going to quickly go over a few more slides that I found really beneficial. So there's the time series analysis. So after you've got your sentiment, your user sentiment, you can discover how it changes over time and find problem areas due to spikes and negative feedback, or even, look at, wow, like after this release, there was this huge spike in positive feedback. Like, we are doing something right, which always feels very validating. So those are the benefits. And then how, well, you get the sentiment using one of the classification models. You group the comments by neutral, positive, or negative sentiment. And you group comments by day, week, month, or year. And then you can integrate release dates as markers to gauge sentiment change after major design changes. But I do want to point out, you still want to be testing your designs with real users using A/B tests. You shouldn't just rely on, something like this to see. You want to be more proactive than that with new design changes. With the lexical dispersion plot, which I kind of described earlier, the benefits to that are you gain knowledge about word offset in your corpus. So you can identify changes through time for n-grams and positive or negative text. So you can, as I said, you can split that lexical dispersion in a positive or negative. So you get sentiment using one of the classification models, plot using the NLTK tool dispersion plot method, and then use n-grams that stand out for information retrieval of comments with recent high counts of negative comments. So yeah, if you're seeing a lot of like can't, won't, don't, like, you know, a lot of negative terms recent, then you might want to look at what's going on in your UI that might have changed recently. And then, as I said in the beginning, information retrieval is one of the most useful things, and one of the most manual things, and also one of the easiest things to implement once you have your sentiment. So benefits by manually reading comments that contain high frequency terms. You can focus on patterns in the UI that users might be having trouble with. Also, you can find user suggestions from these comments containing high frequency terms. And then how, use bag of word model and get the most common words in the corpus, and using them to search and retrieve comments and their sentiments for comments containing those words. All right, so which model or analysis should I use? So this, I just kind of summed up what I experienced as far as like the exploratory algorithms were interesting, but I didn't find them to be like particularly beneficial in exposing patterns that weren't already obvious. And the information retrieval was definitely the most insightful. Tools to get the job done. So if pandas, I guess I didn't really talk about pandas yet, but it'll reduce your code by at least 2/3. Like if you're using just vanilla Python, it's, yeah, my first script is with just Python, and then I learned pandas a little better, and I was like, oh my gosh, why didn't I learn this earlier? So you can use, it has just really cool SQL like features, pivot tables, joins, merges, aggregating functions, and then you know, the input-output methods are really tight too. So the natural language toolkit I've talked about a lot, and it's got a book. And if you're a developer that doesn't really know much about text mining or natural language processing, read the book. It's got great tutorials and great information. And then scikit-learn has some great different modules for classification algorithms, clustering modules, pre-processing, and I'm sure all of you guys have heard about that. So I did put some helpful sites and articles. Some of them are academic, some of them are really developer friendly. So the slides will be posted so you guys can check those out. So what can or what did we find about, oh, we're done? Okay, so we're done. Yeah, wrap it up. Okay, so I already talked about all these points anyway. So it was just reiterating the points that we found in the user interface. And thank you guys for coming. And the slides will be up at some point, right? And yeah, have fun at your other talks. Thank you.